We're back. Okay, I wanted to, maybe this is the first one you're seeing because Lab 1 is due a little later on, but I wanted to go over procedure for plotting the USGS earthquakes. So we're at earthquake.usgs.gov/earthquakes/search, and that will bring up this dialog box. I have already set up an Excel table with 3 columns. I've partially filled it out already to save time. Just going to show you how to do the last one. Number, which is the number of earthquakes in the time interval we're looking at since 1975. Magnitude, of course, which is moment magnitude. And then we're going to calculate the number per year in a minute after we get the last value. So I'll just go ahead and move the be ready to enter in the last box. And once again, we have set up kind of a median. We're sort of binning the earthquakes into discrete intervals, 2 to 2.99. I'm calling 2.5. You could break things down into more fine detail if you're interested. Not necessary for the purposes, for our purposes right now to do that. So the last range I'm going to be looking at is magnitude 6 to 6.99. First we enter in 1975 01-01, which is January 1, 1975, which is pretty much when the record begins at this particular site. We're looking at earthquakes from a minimum of 6. There's nothing actually bigger than 6.99 but just for discipline, we will go ahead and type that in. We want a circle, 47.6 north latitude, 122.3 west longitude. The circle radius is going to be 300 or 500 kilometers. This will be important. This will speed things up for you in the lower magnitude searches. Click on event type, open that up, and click on earthquakes to select just earthquakes. It turns out when we're in this size range, the only thing that instruments pick up is actual earthquakes of that size. So double check. We've got the date, we've got the magnitude range, we've got the lat long, the radius, we've clicked on earthquake or event type, and we're ready to search. And that went quickly. We've got 7 earthquakes in that time interval, and if you scan across, if you're from Washington, this one will ring a bell. This is the Nisqually earthquake on February 28th, 2001. It was a 6.8. Not a bad size earthquake. That's that's the biggest one that we've had in this particular record. But as you know, that's not as big as they can get. So key number here is in that range of earthquakes, we have from 6 to 6.99. We have 7 earthquakes reported in the catalog. So let's go back to this box, type in 7, and now let's calculate. We're going to convert the raw number of earthquakes in the 48 some years since the beginning of the catalog that is available to us. We're going to divide this number, the total number in that time period, by the number of years to calculate number per year. So 16, whoops, we're going to use the cell. Type in the magic word to Excel, magic symbol to Excel to tell it you're going to calculate something is start it with the equal sign. So equal sign cell A2 divided by 48.8, which is the decimal number of years since January 1, 1975, calculates that for us. Now we can just quick trick to paste down that same formula in all these other cells. Select the cell, grab the little handle at the bottom right, and drag it down, and it has calculated all of those number per year values for us, and we're ready to make a plot. So grab magnitude and number per year and just So start at the upper left, drag down, oops, that was a mistake. So upper left, drag down without grabbing the handle on the corner, just grab within the cell. So now we're telling Excel that we want to use that set of data to make our plot. Insert, charts, scatter chart gives us a preview. We click on that. It's not exactly what we'll want. We'll change it in a minute. So scatter. Now, I don't like this especially. I want to make it a little more readable for us. So go over here to the left to quick layout, and bottom left hand, it's called layout 10. That's one I like better. I think it's more readable. So I'm going to resize for readability purposes, hopefully. There we go. And I'm going to get rid of this. It's useless. Gives us a little more viewing area. I've covered up the data table, but that's fine. Now the first thing we want to do is, remember, we're looking at magnitude along the x-axis. That's already logarithmic. We can the mistake where I got into trouble in class the other day was I thought I should make this logarithmic, but that's actually not the case. If you look at the range of data that we've got here, we don't have a huge range of data. We've got numbers per year ranging from close to 0 up to 33 and a little bit. So that's actually not bad for us. We're going to leave that alone. We're not going to change either of these axes to logarithmic, but remember that because we're looking at moment magnitude, that's already a logarithmic scale. So we're pretty much ready to charge ahead. Let's hit chart elements, add a chart element to this thing, plus, hit the plus sign there. We want a, we're going to want a chart title we'll get to in a minute. We're going to want a trend line, and there it is, and that's when the axis gets messed up. So trend line gets clicked, yes. Hit the little right arrow for more options. More options on the trend line. We want to print out the, oh, no, that's not what I wanted. So trend line, more options, and I don't know how that last thing happened. We want to go down here and check the box that says display the equation on the chart. We'll make that use of that in a minute. There's our least squares fit equation. You know, those of you who are doing statistics, you can see how good of a linear trend we've actually got here. So we've got display equation on chart, which I've already done. I'll get rid of that. And you can also display the R squared. It's the goodness of fit. How good a fit is this line to the data? You know, it's not bad. R squared of 0.9. So let's put that up there just for the heck of it. Okay, so at this point, we're kind of good to go, except we want to label things meaningfully. Earthquake. Or how about, let's call it Cascadia earthquake frequency versus magnitude. Cascadia, whoops. Cascadia earthquake, sorry for that, frequency versus magnitude. Magnetide won't work. We want on the y-axis, we want to call that number per year, and on the x-axis we want to call it moment magnitude. So the last thing that remains is just to fix this annoying little axis business. For some reason Excel insists on putting it up here in the middle of the chart. I hate it. So click on the axis, one of the axis labels to select that, right click, Format Axis. Took me forever to find this. Go down to Labels. I think there's probably other ways to do it. So open up Labels and Low, and that will put the X-axis label down below where I feel that it belongs. So at this point, we've got a nice plot of Cascadia earthquake frequency versus magnitude for the data set that we've just searched. There's a bit of noise in the data. You know, we've got, if you want to tease out as much as possible from the data, you could say that the line, the fit of the data to the line is really good for the smaller magnitude earthquakes, but we seem to be missing some of the larger magnitude ones because it falls considerably above the line here. But that might be pushing the data harder than we really would like. When notice that this is there's a minus sign in my equation here. When you go to extrapolate from this data, from this equation, how much or how often we should expect a magnitude 8 or 9 earthquake, you're going to plug in x into the equation here, do the math, and you'll get the y value, and the y value being how often, what's the expected magnitude per year. And it'll get, it actually, because it's using this line, this least squares best fit line, which isn't really real data. It's not, you know, it's an approximation. It's a statistical thing that we've done here just to eyeball it. You will probably get, well, I can just eyeball it and see 8.8 times magnitude 8 plus 6 or minus 8.8 times magnitude 8 plus 53 is going to give us a number less than 1. It's going to give us a negative number. Well, that's not right. So you know, that's an artifact of the least squares calculation that we've done here. So just understand that that's a problem, and go ahead and do your thing.